All right, welcome everyone. We're going to get started. Thank you all for joining our webinar today on remining and the energy transition, which is organized by Earthworks, Earth Justice, and Transport and Environment. In case you missed it, yesterday, TNE hosted a similar webinar that covered the policy implications for remining in Europe, which was recorded and will be up on their website. As the need to create circular economy solutions to address metal supplies becomes more urgent, remining mine waste is touted by policymakers and others as an alternative to virgin extraction for its promise to deliver better community conservation and climate outcomes. In this context, Earth Justice, TNE, and Earthworks commissioned Dr. Ann Mace to research how renewable energy minerals can be recovered from mine waste deposits, the possible benefits and dangers of scaling up remining, and the practices that we need to reinforce gains and mitigate risk from remining. So today we'll hear from Dr. Mace. She's an aqueous geochemist with Buca Environmental based out of Colorado. She specializes in environmental effects of hard rock mining and responsible mining assessment. We'll also hear from Sarah Fields. Sarah is the program director of Uranium Watch located in Southeast Utah. She has been involved in uranium mining and milling and other nuclear health, safe, environmental, and regulatory issues for over 20 years. And lastly, we'll hear from Blaine Miller McFeely, a senior legislative representative at Earth Justice on the policy and legislation team. Blaine works to influence Congress and federal agencies to help protect public lands, communities, and advance environmental health, specifically focusing on issues involving hard rock mining and national forests. We'll hopefully get to take a question at the end, but please put questions in the Q&A function. We'll try to update them as we go so you can see answers in real time, but we'll also post the complete list of questions and answers along with the recording of this webinar when it's finished. So thanks again, and Anne, I will turn it over to you and share slides for you.
Thank you, Jan, and good morning, good afternoon, everyone. It's nice to be here with you. I am going to give a general overview, and there's a lot more detail in my paper and the supplementary materials, which give more information, of course, and remining examples. And I believe the link has been put in the chat. As a definition for remining, remining uses solid and liquid mine waste and byproducts as the source material for, in this case, renewable energy metals and materials. So we all know that there's been an increasing demand for renewables and electric vehicles over time. In the United States, EV or electric vehicle sales passed the 1 million mark last year. Now, demand, as you go forward to the right of the vertical dashed line, is a projection or a prediction. Demand is variable depending on policies, strategies, and other factors. If you look at the diagram on the right, these are the metals that are used in renewable energy technologies, including wind, solar PV, concentrated solar, hydro, geothermal, and energy storage or batteries. And you can see that copper is needed in all of them. Nickel is needed in most of them. Energy storage or batteries probably have the highest need for metals, and rare earth elements represented here by neodymium is used in permanent magnets for wind turbines. Let's see, we should say that, energy storage and battery technology is changing dramatically, so the types of metals needed will probably change over time. Next slide. So there are a number of remining sources. In the United States and around the world, there are a lot of abandoned hard rock mines. By one measure, there's 500,000 legacy and abandoned sites in the United States. If we use the mine waste from these sites for remining, we have the combined benefit of getting value out of the waste and remediating some of these sites. Existing metal mines are also important remining sources because they have, of course, the deposits of wastes and also generally existing beneficiation and processing facilities on site. The focus primarily has been tailings, but there's also smelter slag from these sites and other materials. Coal ash, the focus has largely been on rare earth elements. And then byproduct and primary production is another remining source where There are ongoing efforts to get tellurium, indium, and gallium from different types of waste deposits. Next slide. Sampling remine sources can be kind of tricky. The focus has definitely been on tailings. One of the big advantages of tailings is that they're kind of pre-processed. They're already crushed and ground, and they're generally more consistent in metal content, particle size, and physical characteristics than waste, such as waste rock. But there are safety concerns, and I'll mention that a little bit later. There's little information on the spatial, like three-dimensional distribution of metals and particle size in tailings impoundments, but I wanted to show you the next slide, which is from an antimony mine in China, and here they have done a really good analysis going down to 34 meters deep in a tailings impoundment, and you can see that the concentrations of these elements are higher at the greater depths when they had older operations that were not as efficient as extracting antimony and other metals like tin, tungsten, indium, and tellurium. If you go one click down there, you have 12,000 milligrams per kilogram or 1.2% antimony, which would be pretty good deposit even for primary production. As the methods got more efficient, you have lower concentrations of almost everything, but not tellurium on the right there. So some of these metals that they were not after initially could have higher concentrations in even more recent tailings. Next slide. So this is a general overview of how to, it's a general approach for characterizing and managing tailings for remining. First, of course, you have to identify the deposit. In this case, it's a waste deposit. Community engagements should start from the very beginning, and then you need a sampling plan for how you're going to sample the deposit and get general characterization information, such as how much material is there, what are the total metal concentrations, particle size, and stability. Stability is very important, especially for wet tailings and remining. You need to pay special attention to that. Then more detailed testing is needed. You can't just look at total concentrations of a metal. Mineralogy is important. MLA is mineral liberation analysis, which is essentially how easy is it to get that metal out of this waste. And then other types of analyses that, we always do at these, for tailings and other wastes, like acid potential and contaminant leaching potential. And then designing and testing processing approaches, which generally happens in a laboratory setting, can also happen at a larger pilot scale. And then finally, what happens with all the residuals? Because even with remining, there could be quite a bit of waste remaining. And so this concept of circularity, creating products, and analyzing what we could do with the remaining waste is very important. Next slide. Oh, okay. So I'm going to focus on the US in this webinar. There are a lot of ongoing and proposed characterization efforts by governments. In the United States, the US Geological Survey is leading the charge with Earth MRI. It's a 10-year study on mine waste and tailings and what they refer to as perpetual waters, which would be, for example, acid mine drainage waters. They have pilots in 6 or more states. It keeps increasing all the time. They're looking at how much is there, what is the grade, the ore grade essentially, geochemistry, mineralogy, and a lot of other factors. There is a 10-year time frame on this though, so it'd be nice if we could speed that up a bit. Also in the US, we have some data on remine sources, actually quite a bit, from US EPA's Toxic Release Inventory, or TRI. That gives total metal concentrations in mine waste discharged to land, water, and air. And definitely the largest amount of metal is discharged by mines and to land. So some of the general challenges for these characterization efforts is there's a lack of information on the chemical content and the extractability of the metals in the waste. There are gaps spatially and temporally in a lot of these inventories. And generally, and this is something I was surprised to find, the characterization and processing is generally in the early stages of investigation in the US and around the world. Next slide. So there's certainly no shortage of tailings. By one estimate, there's about 8,500 active, inactive, and closed tailings facilities around the world, and producing about 217 billion cubic meters of tailings. Copper mines definitely have the highest amount of tailings, but there are other ones as well. And let's go to the next slide, which is the US one. So the toxic release inventory, looking at the tons released to mostly to land, but to all sources for cobalt, copper, manganese, and nickel. This was from 2021 compared to annual consumption. The bars are the amount from 2021. The blue circles are annual consumption in the United States, and the green is everything. I added all the metals up from the time TRI started to 2021. You can see that the annual consumption in the US and the total TRI is about the same. And of course, we're not trying to replace all the annual consumption, which is for all uses of these four metals, but it does show that there's quite a bit of potential in these wastes. Next slide. 1 minute left, okay. Why don't we just skip over this? There's lots of examples of remining, but I could only find five that were in, full operation. 3 of them are in Africa. 3 of them are gold. And of course, we're interested more in renewable energy metals. Zinc from zinc-based metals in Australia. And then the project in Uganda is not what they were after initially. It was cobalt from copper mine tailings and using bioleaching methods. And bioleaching, in other words, using microbes to extract the metal, seems to be the most common one used. Okay, next slide. So the risks and benefits, I hope I'm going to get a little more than 1 minute here. The risks are, there's definitely an information gap on both sides of this, the risks and the benefits. Thank you. Remining, when you think about remining compared to primary production, some of the similar risks are water quality impacts, tailings dam failures, and community impacts. However, others are unlikely to occur. For example, we're not going to be creating open pits for remining. So this landscape level destruction is not there. And then changes to stream flows and groundwater levels are less likely with remining. Other risks that have been mentioned are delaying closure. If you continue to open a mine or reopen a mine for remining, are you ever going to close it? Also dust and reactivating pollutant pathways. And then what do you do with the remaining wastes? Next slide. And I've mentioned a couple of times this tailing dam failures. There are 2 known tailings dam failures at remining operations, one in South Africa and one in Romania. And these are quite recent, 2022 and 2020. And these both were associated with wet tailings. And there were fatalities and extensive fish kills. Next slide. So on the benefits side, of course, the benefits for remining is one of them economically is that it increases domestic supply. And probably where you get the biggest bang for your buck is cleanup of mine impacted sites, especially abandoned ones, and improve land and water quality. There is a reduction in greenhouse gas emissions and energy and water use. Crushing and grinding of mined ore from primary production is the #1 energy use in mining, and it accounts for 3% of all electrical power usage around the entire world. So it's a lot of energy there, and also water use. Some studies in Chile have shown a 40 to 50% reduction in water and energy use and capital and operating costs compared to primary production. The opportunity for reuse of some of the water in these wet tailings can be reused, and the risky tailings facilities can be redesigned. Last slide. So what do we need to move this forward? The first couple are in process, but have a 10-year timeframe by the USGS, characterize, remind sources, prioritize sites. We also need legal protections. We'll hear about that in a minute here, requirements and incentives. Best practices for remining do not currently exist. Of course, some can be borrowed from responsible mining initiatives like IRMA. and then safe processing methods and incorporating metals into the value chain. How can we do that so that these metals can be used effectively for renewable energy technologies? Thank you.
Thanks so much, Anne. Much appreciated. Just a reminder, folks should feel free to put questions in the chat. We'll try to answer them in real time. If we have time at the end, we'll take one or two. So Sarah, I will turn it over to you.
Thank you for providing this opportunity to participate in the webinar. I'll be covering some issues related to remining and uranium production. This is in the United States. There are two aspects of uranium production related to remining or reprocessing to obtain uranium or other minerals from mine waste rock piles or uranium mill effluents. Waste rock and low-grade ore from existing uranium mines can be taken to a uranium mill to be processed as ore. The only operating conventional uranium mill in the U.S. is the White Mesa Uranium Mill in San Juan County, Utah. Waste rock and low-grade ore from their permitted mines have been processed at the mill in the past. The mill has been paid to receive and process materials from the reclamation of the Mount Taylor uranium mine in New Mexico. The mill is adjacent to the community of the White Mesa Band of the Ute Mountain Ute tribe. The White Mesa community is adversely impacted by the operation of the mill. They are particularly impacted by the radioactive and non-radioactive emissions from the mill. The residents really complain about the smell. There is a yearly spiritual walk and protest march drawing attention to the impacts of the mill operation. There are hundreds of abandoned and inadequately reclaimed uranium mines in the Four Corners region. That's Utah, Colorado, Arizona, and New Mexico. Most of the mines were on federal lands administered by the Bureau of Land Management and/or the U.S. Forest Service or the Department of Energy under their lease program. In Utah and Colorado and New Mexico, the removal of waste rock and low-grade ore from the sites on federal lands would require a permit by the federal agency and the state mining authority. Hard rock mines on federal lands in Arizona are not regulated by the state mining agency. They only regulate mines on state land or private lands. It is not economically feasible to permit all mine sites and send waste rock or low-grade ore to the White Mesa Mill. The only way it's economically feasible and advantageous is if the mill owner is paid to receive and process materials from the cleanup of mine sites that have been abandoned or reclaimed. Energy Fuels wants to be able to process materials from the cleanup of abandoned mines on the Navajo Nation. It is my understanding that the EPA and the Navajo EPA do not want to send the waste from the Navajo Nation to a site near another tribal community. And it would be the Ute tribal community. If large amounts of materials from the Navajo Nation and other mine cleanup efforts are sent to the mill, eventually this would require the construction of two new tailings impoundments. That would be 5A and 5B, which have generally been approved, but they still need a license amendment. New impoundments, as with the existing impoundments, would destroy significant cultural resources on White Mesa. White Mesa is its own archaeological district. These cultural resources include ancient pit houses, kivas, food storage structures, artifacts, and burial sites. So there would be a really adverse impact if they would receive large amounts of materials from the Navajo Nation. The White Mesa Mill has been reprocessing liquid effluents stored in tailings impoundments for vanadium. Currently, the mill is producing uranium and a rare earth element concentrate from the processing of monazite ore from Georgia. The mill is being modified to be able to separate individual rare earth elements from that concentrate. There are some legal issues related to these processes. Reprocessing solid uranium mill tailings at a uranium mill site is not feasible. Most of the historic uranium mill sites have been reclaimed and are now under the control of the Department of Energy, though there are ongoing remediation sites in Utah and in Wyoming and in New Mexico. Ablation. Another important aspect of remining and production of uranium is the use of ablation to process mine waste and low-grade ore on site. Dissect Technologies has proposed the use of high-pressure slurry ablation uranium removal system to clean up uranium mine sites on the Navajo Nation and elsewhere. DICE worked with the EPA Region 9 and the Navajo Nation EPA to conduct demonstrations in 2022 at locations in the Navajo Nation and submitted a license amendment request to the NRC entitled Application for a Performance-Based Multi-Site Radioactive Materials License to operate a high-pressure slurry ablation remediation system. So the NRC conducted a regulatory review and informed DICE that consistent with previous instances where NRC has considered the applicable statutory and regulatory requirements for such technology, the staff has determined that this technology is uranium milling as it produces Atomic Energy Act 1182 byproduct material, and then it is thus subject to the regulations at 10 CFR Part 40 and Appendix A. DICE had wanted just a source material license. But in response, DICE went to the commission itself and asked them to reconsider the NRC staff decision. The commission was then, they directed the staff to evaluate the advantages of different options for the licensing of emerging technologies used for remediation of mine waste. And in response, the NRC issued what they call a SECI paper. So SECI-23-0055 options for licensing emerging technologies used for remediation of mine waste was issued in June of 2023. And I'll put a link to that document in the chat. So the NRC evaluated several options for licensing of these new technologies, and they concluded that option one was the most appropriate, and that would require a uranium milling license, but would also allow for certain exemptions. And an important exemption would be how they would dispose of any waste from this processing, because at conventional mills, they must go into a licensed double line tailings impoundment. So the NRC commission has not yet approved the SECI and has not yet officially determined that any use of ablation or other so-called advanced technologies to deal with waste would be a Part 40 licensing action.
Thank
So
you, Sarah.
ablation basically concentrates the uranium. So this is an ongoing and important issue because the commission has not made a final determination. Okay, thank you.
Thank you so much for that, Sarah. We really appreciate that perspective around uranium milling. Blaine, I will turn it over to you to take us home with policy recommendations.
Thanks, Jan. Thanks for having me. So this report, as we've obviously heard, has a ton of great information, and I'm going to speak to the U.S. need and sort of policy implications. I want to make sure to acknowledge not just the report's author, Anne, who gave a great presentation, but also Aaron Minces with Earthworks, who's an expert on the policy implications as well, and is answering questions that may arise. So just to keep this short, climate change is already here, and we have to look at all suitable and truly sustainable options to fight it. At the same time, we must understand the consequences of those options in order to make decisions and regulate appropriately. And that's why Earthworks helped to commission, or Earth Justice and Earthworks helped to commission this report. So the US is already investing millions, if not billions, into remining, whether it's in hard rock or coal ash or other tailings ponds and so forth, through legislation like the IRA, the Big Climate Bill, or the Bipartisan Infrastructure Law. From coal ash, rare earth metals, remining pilot projects, to Oak Ridge National Lab research. It's like there's a remining announcement just about every month. So we must move quickly right now because there's a lot to do in the policy space to learn about and mitigate the risks and drawbacks that we just heard about while taking advantage of the benefits. So first off, as discussed, we need more data, and USGS is going to be key to that for the potential for minerals and so forth. So there are certainly benefits to getting more primary minerals for clean energy technologies, while also potentially advancing that mine waste cleanup, as Ann talked about. But those benefits are only realized and risks are only mitigated if the proper standards are in place to make sure everything is done in the most just and sustainable way. The risks are real, as the previous speakers have raised, whether it's coal ash or uranium or anything else. We can't release more contaminants into our water, air, and soil, and we can't further perpetuate environmental justices like the destructions of sacred sites and other special places. Communities should have a right, whether it's remining or mining, to clean air, clean water, a healthy environment, and deserve a say in protecting places that are sacred and special. That's why, just like mining, for remining, we need stronger mining and remining laws that require better due diligence, protect tribal rights like free, prior, and informed consent. For example, the US must condition all federal remining support, including the lots of tax credits that are out there for it, 48C, 45X example, upon the recipient's commitment to perform ongoing human rights and environmental due diligence across their supply chain, in accordance with internationally accepted standards like free, prior, and informed consent. At an absolute minimum, remining needs to adhere to current mining laws, but we need to be explicit and concrete, but have explicit and concrete best practices. And remining can't just be an excuse to make a profit and keep putting off reclamation. So I like to put it simply: remining is mining, and it needs to have the standards and laws that will apply to both. So most of what I just said is really applicable to all mining. I will say that coal ash, on top of it, has some unique needs. And because just like hard rock tailings, coal ash is toxic waste and has the hazardous pollutants, metals, neurotoxins that threaten human health. And so we can't use it. We can't delay cleanup because they pose additional threats to communities. And just like hard rock tailings, coal ash and any processing chemicals must be handled with proper health and environmental safeguards during the remining and have those high standards. Should never be an excuse to delay proper and swift closure of coal ash dump sites and tailing ponds. But one main point I want to make on coal ash is that it needs to be remembered it must not incentivize creation of new coal ash. Existing dump sites in the US contain enough ash to meet demand levels for rare earth elements for many years, assuming full recovery, and more coal ash will never be worth the harm coal mining, coal burning, and coal ash perpetuate on communities in the environment. So to sort of wrap this up, the need for high standards are why we urge Congress to take up legislation like the Clean Energy Minerals Reform Act, updating the 1872 mining law, to update our mining laws to include strong environmental, public health, and community protections alongside other efforts like the Environmental Justice for All Act that would strengthen NEPA and tribal consultation for mining projects. And that has to apply to both mining and remining. We don't have to make a false choice between fighting climate change and protecting communities. With the proper policies and regulations in place, we can do both, and remining is one part of that. Thank you.
Great. Thank you so much, Blaine, for that very well condensed intervention. Really appreciate it. So we hit the top of the hour. We want to thank everyone for participating in this webinar and for, trying out this new kind of half-hour format with us. We appreciate you joining and being part of this experiment. Thanks to Anne, Sarah, and Blaine for the important information that you've shared with us. We will send around a recording of today's webinar, the complete list of questions and answers that we received from the webinar, as well as Anne's slides, so anyone can see them. We'll also post those all online on our various sites. So stay tuned for more information, and please feel free to reach out to us at Earthworks and Earth Justice if you have more questions or are looking for more information. Have a great afternoon, everyone, and thank you again.
Thanks, everyone.